Hello, and welcome to 10.7. Today we're going to be graphing with vertical shifts. So we're going to be doing the exact same process as what we were doing before, where we're finding the amplitude, the period, the x scale, filling out our chart, and then we're going to be just shifting the entire graph up or down based on our k value. So here's the new equation. Just the one little adjustment is the plus k. So this is going to either shift it up or down depending on if it's positive or negative value that we're adding. All right, the amplitude is the same. Period is still the formula 2 pi divided by our b value. Remember that a is what's in front of the sine or cosine function. B is always going to be inside with the x. And then our x scale is just taking that period, multiplying by 1/4 or splitting it into 4 parts. The one thing that is also going to change today that we have to be a little bit more cautious of is our range, because we want to think about the highest and lowest values after we've adjusted it with our vertical shift. And we'll kind of see that here in just a second. So let's go ahead and graph this first function. So what we're graphing here is y equals sine of x plus 2. So this is the parent function just shifted up 2 units thanks to the plus 2. So let's go ahead and fill everything out. The amplitude would be our a value, which we assume there's a positive 1 there. The period would be 2 pi divided by our b. Since we don't see a number, we assume that there's a 1 in front of x. So then our period is the standard 2 pi, and our x scale, if we just take that and fill it in over here, that would be 2 pi times 1/4, which is the same as 2 pi over 4. So I can just put this over 1, which reduces to pi over 2. So this is going to be the standard period. So then our x scale count goes pi over 2. The next one would be pi, 3 pi over 2, and 2 pi. Remember that your period should always match the last term in the x grid. So those match up, so we hopefully did that right. Next thing is the y value. This is going to come from using our coordinate pairs. So these are the 4 pairs we're going to use. The first one is 1, 0, 0, 1, -1, 0, and 0, -1. And because we're doing sine, we want the y values. So I'm going to just highlight those one more time here. And then we just follow that pattern for each of them. So the very first one, this is where we start over here. So then it goes 0, then we go to the top, which is 1, back to 0, -1, and we end where we started at 0. Now our a value is 1, so we don't necessarily need to multiply this out. We could. We would get the exact same values since we're multiplying by 1. So then the thing we need to adjust for is our vertical shift. So I'm going to add that in here. Since we're going plus 2, I'm going to count 1, 2, and then I'm going to draw a line through that. All right, so that line is just going to represent our vertical shift and how we've adjusted the whole thing. Hold on, there we go. Gotta make it parallel. So now we're gonna fill in the exact same x scale values like we were doing before. We're gonna do our 4 tick marks. So I'm gonna do pi over 2. I'm gonna do pi, 3 pi over 2, and 2 pi.
Next up is Academic Olympics. If you're in Academic Olympics, please head down to the Ox Gym.
Okay, so now the main thing with the vertical shift is like our high and low values. This point here is now going to be associated as our 0, 0. So we are going to go up and down 1 point from that new shifted point. So our new 0, 0 is actually going to start here because we have to shift everything up 2 units. That's why I drew this new line so that we have like a new x-axis essentially. Okay, and then at pi over 2, we're just going to go up 1 unit from there. And then at pi, we're back to 0, which is actually on our new line. And then at 3 pi over 2, we're going to go down 1 unit, which would bring us to 1 right here. And then we end in the middle. So this is the same shape as the sine curve we saw before. We could go back and look at the old notes if we needed to, but all it did was it shifted up the entire graph 2 units. The process, everything else is the same there. Now, I saved the domain and the range for last because I just wanted to talk about the differences here. Domain is still going to be from negative infinity to infinity because we're continuing left and right forever and ever. The range, however, has a new set of numbers. It's no longer the negative a to the positive a. It is going to be from your highest value to your lowest value because we shifted the entire thing upwards. So it looks like our range, our highest point is at 3 and our lowest point is at 1. So we're going from 1 to 3, essentially, is the entire shape of our graph. So that's from 1 to 3. It's not a major change. It makes sense because that's what we see on here, but just one adjustment you want to be careful of. All right, let's go on to the next one. Write the equation of the sine curve shown. So right away, hopefully we can see that this has definitely been shifted downward. This is the normal sine graph, but it looks like we've gone down 2 units. Come on. Oop. Just trying to make this even here. Okay, so we've gone down 2, and now we're trying to write the equation. We know it's a sine graph, so we're going to just leave some space. So y equals sine x, and we already mentioned that it went down 2 because that's where our new midline is. Now we have to be able to identify the period and the amplitude. The amplitude is the distance above and below our midline. So it looks like we go up and down 1, which makes this nice and easy. That would be a 1 there, or you could just leave it as sine of x. Now the only thing that is kind of evident that is definitely changed is the period. If you notice, we're counting by pi over 4s to get here. And if we go from the center, we follow our line, we go up to the top, and then we go back to the center, down to the bottom right here, and then we end where we started. So this is how we can identify an entire period, because it has to complete that standard pattern. And that looks like it's a distance of pi. So if our period is pi and the formula is 2 pi over b, we're trying to find the b value that would make this true. One way you can do this is to set it up as a fraction equal to a fraction, and then you can cross multiply with both sides. You would get pi times b equals 2 pi, divide by pi, and we see that the value is b equals 2, which makes sense because 2 would make our period smaller, and 2 pi divided by 2 would fit. So this is our equation. All right, on to the next one here. The cosine wave y equals a of cosine bx plus k. We have our amplitude, we have our period, all of this. So now we're going to go through and do cosine. So the amplitude would be our a value, absolute value of it, which is 2. Our b value is still 1, so 2 pi over 1 is 2 pi, which means that we're going to get the exact same x scale as the one we saw last time. It's just going to be pi over 2 ultimately. So that's what we're counting by, is pi over 2. And we end at 2 pi. Okay, so now when we do our values down here to finish off the x values, we got 1, 0. Sorry, not x values. We want to do the y chart with the x values because we're doing one and 0, -1. Okay, so one more time. Oop, wrong one. We are doing the x values now because we're doing cosine. Okay, so we would have 1, 0, -1, 0, back to 1 where we started. Our a value this time is 2, so we do want to account for that. So we want to start at 2, 0, -2, 0, 2. And then I'm just going to cross out the middle column since we no longer want to use that. Okay, so now definitely think about this one. We have a midline starting at -1. That's where the center of our graph is now going to be placed. So I'm going to do some tick marks here. So let me just go 1, 2, 3, 1, 2, 3. You don't have to do this every time, but I'm adding some additional tick marks because I know that we're going down by 1, and we're also going to be adding and subtracting by values of 2, since our amplitude is going to take us 2 above and 2 below that point. So -1 is going to be our center. Okay, and then since we're going 2 above that point, we would have to go up to +1, and then we also need to be able to go down to -3, because that would be 2 below -1. Now we're ready to graph. So our first point is 0, 2, and that is going to start up 2 units. I actually shouldn't have put a dot. Let's see if I can erase it here without getting that. I just wanted to identify that as our new origin point. But the first point is actually going to be up here. Okay, and then at pi/2, I should probably fill in the x-axis here. We'd have pi/2, pi, 3 pi/2, and 2 pi. So we had our first point there. Then we go down to 0. And then at pi, we are -2 below our line, which is down here. Back to this one, and we end at the top, which is going to be right here. So now when you graph this, remember that cosine is also a wave, and this is just that standard function. All right, and then we have the domain and the range. Domain is always going to be the same because it extends forever and ever left and right. The range has a new set of numbers now. So our highest and lowest points, our lowest point is -3, and we're going up to +1 is the highest that we reach. And that has a difference of 4 because our amplitude was 2, so we go 2 above and 2 below. And now we've graphed that one. We're getting close to the end here. All right, so we got y = 1/2 sine of 2x plus 1. Our a value is 1/2. The period this time, we do have a 2 here. So we have to take 2 pi divided by 2, which is pi. And then if I take that and use it for the x scale, we would have pi times 1/4, which is pi/4. So now we're counting by pi/4s, which is the same idea as counting by 1/4. So we'd get pi/4, pi/2, 3 pi/4, and the last one would be 4 pi/4, which is the same as pi. And that's what we want to see here. Okay, the y values. So since we're doing the sine values, it's the same as all the other sine ones that we've done. I mean, I can write this out one more time. 1, 0, 0, 1. It's not bad to practice this. -1, 0, and 0, -1. So since we're doing the y values, it starts over here at 0. It goes 0, 1, 0, -1, 0. We use those same ones every time for sine. And then our a times y would be 1/2 times all of those. So it'd go 0, 1/2, 0, -1/2, 0. I'm just going to cross out that middle column. Now we are starting at the point 1. So this one might be a little tricky. So we're starting at 1. I'm actually going to add in some increments in between
All right,
here.
next groups are environthon and
We'd have
weightlifting.
1/2.
Please make your way down to the oxygen, envirothon, and weightlifting.
Okay, so 1 is in the center there, 1/2 is in the middle, and then we would have 1 and 1/2, which is the same as 3/2 above it. So I'm going to draw in the midline. And then I'm going to list out our points. So we got pi/4, pi/2, 3 pi/4, and pi. And we're back here at 0 to start. So the very first one for sine should start at 0, 0. But remember, this is now your 0, 0 because we've shifted the whole graph up. And then it goes up by 1/2, down to 1/2, and we end where we started, that standard sine shape. And this one does look a little thinner, which is correct because this would be a vertical shrink thanks to the 1/2. All right, our domain, same thing as before. We're going from negative infinity to positive infinity. And our range this time, we have a minimum value going from 1/2 up to 3/2. Just your highest and lowest points that you reach. All right, a couple more to go here. Another one of those, write the equation for the curve shown. For this one, it looks like our center is right here. So it looks like we're going, there we go. All right, so it looks like we've been shifted up 1. We know that's the center because it goes above and below the same distance. So then that tells us that we have a +1 here. The distance between our highest point and the midline is also a 1. So we can say that this is going to be a function with a +1 at the end. We're going to have a 1 for our a value. And because we're not starting at our origin point or what we would consider the shifted point, this would actually be a cosine function. We're starting above it. So then it's y equals 1 times the cosine. And for cosine, it's easiest to look from top point to determine the period. So if I look from here to there, it looks like we're going from 0 to 2 pi. So if 2 pi is our period, that tells us that the b value has to be the standard b equals 1. So then this would just be cosine of x. I'll just add the +1 a little closer here. And there's our equation. So not too bad on this one. Last one, and this has a little bit of everything. It's got a negative a value, we've got 2 pi, and then we also have a vertical shift of -3. So our amplitude on this one would be +1. Remember that the absolute value changes that from negative to positive. Our b value is 2 pi, so whenever you have 2 pi divided by 2 pi, you just get 1, which feels weird, but we can have a period of 1. And then our x scale, if I replace this here, 1 times 1/4 is 1/4. So we're counting by fourths, so we'd have 1/4, 1/2, 3/4, and 1. All right, I'm going to fill that out on here really quick. So 1/4, 1/2, 3/4, and 1. Now for our values here, we have to be very careful because we have a vertical shift of -3. 1, 2, 3. But we also have to go down 1 more because we have a value of 1 for our amplitude, so that's going to make us go down a little bit further. So I'm just going to extend this line a little bit. So now I'm going to draw on the midline, which would be down here at -3. I really got to work on my straight line drawing. Okay, there we go. And then this is -3, this would be -4, and -2 above it, since we're going up and down 1. This is the cosine function, so these would be the x values if we were to make our chart over here. For the sake of time, I'm just going to fill these in since we've seen it a lot of times. So it goes 1, 0, -1, 0, 1. Our a times y value is going to be -1 times all of these. So this would be -1, 0, +1, 0, -1. Okay, so our first point is at 0, -1, so that's just 1 below our line. And then it would go up to 0 at the next point. It would go up 1 above. And then we would just continue the pattern. So this is just an inverted cosine graph. Nothing too crazy. Just make sure to account for that -1. And then our domain would go from -infinity to +infinity, and our range would extend from our lowest point. Be careful here because negatives are tricky. It goes from -4 to -2. You do want to make sure you write it in that order. And that is it for the trig.